Namaskar, hello and a very warm welcome to CIET NCERT's live phone-in interactive program. This is our special virtual lab series. I'm Tanvi Khurana and virtual labs are different from physical labs, as you all know by now, because we have done a lot of sessions on this virtual lab series. So virtual labs is something that you can operate at the comfort of your own home, and all you need is some internet connection of yours, and you have to take out time from your busy schedule. So all the students, you are going to enjoy this particular simulation that we are going to demonstrate in front of all of you. Today we are going to take up a simulation of maths, and this is for all the students studying in grade 6. The demonstration of simulation on exploring angles. Yes, we are going to explore multiple angles, but what all angles are those? We are going to tell you that in a short while. So if you have questions, if you want to be a part of this program, you want to do this simulation along with us, please reach out to us. You can raise your questions, your queries. You can call us on our number, which is 8800440559. Or if you want to email us, the email ID is diksha.training@ciet.nic.in. Apart from this, at this moment you're watching us on PM eVidya channel number 6 to channel number 12, and also on our YouTube channel, which is NCERT official. In the live chat box, you can write down your questions, your queries, and simply share them with us without any hesitation. Well, we have a sign language interpreter, and she'll be interpreting each and every word that we are going to discuss in this program. Let me introduce her. She is Anushka. Anushka, very warm welcome to you. So she's going to be here throughout the session, and she's going to help you with the sign language interpretation. Let me please welcome our guest for today. We have with us Dr. Jaganmohana. Sir, a very warm welcome to you.
Namaskar. Thank you.
Sir is an assistant professor from CIET NCERT, New Delhi itself. So let's begin with this conversation. Like I said, virtual labs are different from physical labs, and virtual labs has a certain purpose. So let me ask sir, if you have to define virtual labs in layman's language, how would you define that, and what exactly is its purpose?
Okay, fine. Thank you, ma'am. Actually, virtual labs are simulator environment where it could be enables the students to learn and engage with a direct experience, and also it could be provide a self-paced learning, and with the help of this self-paced learning, the student could get the immediate and real-time experience and immediate feedback also. As we know, NEP 2020 and NCF emphasize about the experiential and experimental learning, where the stimulations they have to do the practicum and experiences through the virtual labs. This is the main purpose. As we know, mathematics somehow as an abstract sense, these virtual labs could convert the abstract sense to concrete sense. This is the main purpose. We could adapt these virtual labs in the teaching learning mathematics.
Okay, so let's talk about the topic for today's simulation. It's exploring angles. Okay. There are multiple angles in maths.
Yes.
So which angles are those that we are going to explore in this simulation?
Yeah, actually, as per the size of the angle, and there are different types of angles are there. That is, one is acute angle, second one is obtuse angle, and third one is right angle, and fourth one is the straight angle. And apart from this, reflective angle also there, and complete angle also there. These are the some of the different types of angles based upon the size of the angle.
Shall we go towards the demonstration path, sir?
Sure, ma'am. First, I would like to show how to navigate this QR code with the help of Diksha app.
So you have a class 6 textbook here?
Yes. Okay. I have a class 6 textbook, and now we are focusing the chapter 2 lines and angles.
Okay.
Now I will show the QR code, how to scan and how to navigate the particular chapter here. So once we open the Diksha app, with the help of the QR code. I have been scanned that QR code. Now we could see here different type of filters. So through that filters already I have mentioned here in the filter chapter 2 lines and angles, and under that as a last resource as a virtual labs. So if you go down here, as per the today topic exploring angles, that is the last subtopic. Under the last subtopic we could also observe here there are 4 types of resources. One is theory, second one is procedure, third one is simulation, and last one is the self evaluation. Okay. This is the way we could navigate with the help of the mobile also.
Okay. So one can easily download the Diksha app and operate it on the desktop itself, right?
Yes, ma'am, definitely.
Okay. And if we have to show the simulation, is it easy to operate it on the desktop or the mobile phone?
Actually, as a more flexible with the desktop or laptop.
Okay.
If there is no option, then we could go with the mobile too.
Okay. So for now, let's just show all the viewers on the desktop mode itself.
Yes, yes.
Okay.
Here, first I have to go with the Diksha portal, diksha.gov.in. So we could see here the home page of Diksha portal. In this home page, we can see here different type of resources: textbook, video, interactive content, courses, and all other subjects. Now I will go through the textbook here. Then we can get some filters as a left side corner. Now you could see the board and organization, medium of the textbook, class. Here I am going to choose the class as a grade 6, and then subject, as we know, mathematics. And the last option, it's user, type of user, it's optional. I could go with the teacher here. Then we can see here grade 6 mathematics textbook icon. We have to click on there. Then as a default we could get the chapter 1 of the particular textbook. So here I want to go here as a remaining chapters. Now as per our discussion, lines and angles as a chapter 2. So under chapter 2 here different resources are there. I will go through the virtual labs, and here our topic is exploring angles. So under this exploring angles we could see different type of resources. One is simulation, theory, procedure, and self evaluation. Here I want to click on this theory part. So in this theory part we could see on the screen what is the objective of this particular chapter and concept, and in the theory they have mentioned what is angle and what are the keywords of the angle, how to name the angle. Like angle, we could see here angle DBE or angle EBD. This B is the vertex here. So those are all keywords also clearly they mentioned as a theoretical part, and they have already mentioned part of angles, size, what is the size of angle. A size, it's just like a rotation of or amount of turn in between two arms of the particular angle. So that is called the size. While measuring that size we could use the unit as a degree, that one also mentioned. And as we discussed here, different types of angles are there also there, and based upon this theoretical what the student could able to learn, those objective also they have mentioned here. This is as a part of the theory. And then the next step is procedure. This procedure just like a navigation, how to navigate these activities. So if the user might be as a first time user, they have to be clearly read and understand this procedure, how to navigate the entire activities. This is about how, like just like a index for the first time users. And the third one is simulation part. Here the main activities will start here. Just I will make the screen as a more visible as a big screen. Now you could see here different type of icons will come here, what type of activities we could perform through this particular simulation part. Give a minute, it's loading.
So,
Yes. So, now we can see here exploring angles, different type of activities we could see here, just start stimulation. So, in this particular home page, this white grid part is called like workspace, and here we could see with some questions also, and here identify the angle is one type of activity, measuring angle as another activity, drawing angles as another, and angles in clock. So, there are 4 types of simulation parts here. Here the first one, as we know in this workspace, already one angle already it has been mentioned. The angle we could see here 155 degrees. So, this 155 degrees, what type of angle? As we know here acute angle, obtuse angle, right angle and straight angle. So, if the angle more than 0 degrees and less than 90 degrees, that is acute angle. If the angle exactly 90 degrees, that is right angle. If the angle more than 90 degrees and less than 180 degrees, that is obtuse angle, and the straight angle means it is complete 180 degrees. So, based upon this angle is obviously as obtuse angle. We will see here it is already mentioned correct 150 degrees as a obtuse angle. If we go with the next question, we can click here next question, or we can also reset here. So, if we click on reset, obviously the next question will become, or we can also click on the next question, it will come the as per as the next question. For example, here the 60 degrees angle is there. So, obviously this is the acute angle. So, this is the way we can go with how to identify the angle, and the next one is measuring the angle. So, here you could see some instructions also there. Drag the protractor from the tool pen into the workspace, align it and measure the angle. And also you could see here, move the protractor, observe the figure and enter the correct measure. That means here they have given a figure of the particular angle, but they haven't mentioned what is the particular angle, the number of the angle, that one. Now we have to drag the protractor here. In this protractor we could see like some measurements are there from right to left and left to right also, and here this point it indicates the center of the protractor, and this line indicates, this straight line indicates the base of the protractor. So, how to measure the angle of this particular angle with this help of the protractor? Just we have to ensure the middle or center of the protractor should be on the vertex, given vertex, and also we have to ensure the one of the arm should be quite parallel to the baseline. So, here this arm OA, it is exactly parallel to the baseline, and also the center of the protractor exactly on the vertex. Now, we could see what is the measure of this particular angle. So, while from A we have to measure this 0 degrees and up to 170 degrees. So, while measuring we have to either we have to measure with left to right or right to left, and also one more consideration also this outer and inner. There is the two scales, one is outer scale and another one is the inner scale. So, we can measure both ways here, either outer or inner way, or left to right or right to left. Here while measuring here, we could see here right to left, it is moved from 0 to 170 degrees. So, we have to enter this 170 degrees here. Now, we will check whether our answer is right or not. Correct, the angle is 170 degrees. So, in this case we can also go with one more thing here. Now, if this is the one more type of question, we will go and drag the protractor here, and we will coincidence that center of the protractor exactly with the vertex. Now, the baseline also exactly on the arm OA. Now, we have to check from left to right 0 to up to what degree here? 140 degrees. We have to enter this 140 degrees. Then we will check whether it's right or wrong. Yeah, correct. The angle is 140 degrees. So, sometimes there is a chance the student could be do something wrong also. We will see that one also. For example, this one student wants to measure this angle. Just we have to coincidence that vertex as well as the baseline. Here, for example, 0 to up to 75, in between 70 and 80 there is a 5 indicator also. This is actually 75 angle, but instead of 75 angle the children might be confused, he or she might be entered 70 degrees. Then we will check its mention, try again, align the center at O, the baseline along OA. So, it has given some hint. So, with the help of the hint, this is also called like immediate feedback. With the help of the hint, the student can be rectify that one, then he can cross check again clearly, then he or she could be enter a right one. Now, this is the correct angle. So, this is the another type of activity with simulation, and the next one is drawing as an angle. So, while drawing we could also see here enter an angle in the box. So, first we have to be enter the angle, like what angle we are drawing there, either acute or obtuse or right angle or straight angle, or what we have to enter the particular angle. For example, I want to draw a angle with 75 degrees. So, it is already mentioned here this angle as a acute angle. So, while drawing a particular angle here, first the next it indicating click anywhere in the drawing area to make the vertex 0. So, first we have to be put a dot as a vertex here, then click another point to make a end from the base ray as a OA. Now, I am drawing a one arm as a base arm, that is OA. So, now one arm already is there. Now, we have to be draw the second arm with the help of the protractor. So, now as we know exactly the center of the protractor should be on the vertex and the baseline should be coincident with the arm OA. Now, once we ensure both vertex and arm OA with the baseline, now we have to be drag the second arm up to the 75 degrees. Yeah, now exactly it is a 75. Now, I am combining this O and B line. See, on the screen you could see the vertex 0 and one arm OA and second arm OB. In between, the distance between OA and OB, it is a 75 degrees. So, this is the way we could draw the particular angle, and here also the immediate feedback we could observe here, well done, your construction as a 75 degrees. So, this is the way we have to be draw the angle. I will show one more time. So, first we have to set the angle. Here I want to set as a 90 degrees, exactly right angle here. then it's asking put anywhere on the this workspace the cursor. I have mentioned here vertex, and also I have mentioned the first arm as a OA arm here. Then I have to be ensure this vertex should be on the exactly midpoint of the protractor, and now I have to move the second arm up to the 90 degrees. So this is exactly the 90 degrees. Now I am connecting this O with the point B. See, on the screen we could see vertex, arm arm OA and arm OB, and in between these two arms there is exactly 90 degrees. This is the way we could draw the angles with the help of the simulations of this virtual labs. And the last one here, like some with the help of the real time examples, like as we know a clock, while rotating the clock there is a angle in between the two needles or two handles of the particular clock. So how to measure that angle in between the particular two handles of the in the particular clock? Now we could see here, here they have mentioned identify the type. First here they have different type of options. One is identify the type and find the angle and measure and classify the angle. First here, as we know, this angle it's more than 90 degrees. So obviously this is called as obtuse angle. Here, yeah, we could see here, and also we can check this one with the help of the protractor too. Yeah, here the angle is almost 120 degrees. So we will check the answer. The answer is correct. The highlighted angle is obtuse angle. So this is the way we can also try how to identify the real time experiences with the help of the clock or something else. And here we will see one more thing, find the angle. Here we have to find the angle at the time of 1 o'clock. So we have to drag the protractor here and coincide with the vertex, and we have to ensure the baseline should be coincident with the one of the arm. Now the angle is 30 degrees. Now I will enter here 30 degrees, then we will check our answer. Correct. 1 hour division multiply with the 30, that is equal to 30 degrees angle. That means in generally in the clock in between like 1 hour indication between 12 and 1, that is as a fixed angle, that is the 30 degrees angle. So we can also do one thing here, we can manually also we can adjust this in between the angles. For example, here in as a 3 o'clock, what is the angle in as a at the time of 3 o'clock?
Right angle.
It's a right angle. We can also check with the protractor. Yeah, this is exactly 90 degrees. So here we have to answer here what type of angle. It's a right angle. Now answer as a correct. So this is the way we can also do with manually. We can also cross check and manually we can adjust these needles and both hours needle and as well as the minutes needle, and also it could be automatically we can also reset with the help of the reset button. So this is the one of the activity, find the angles and identify the angles, and the one more also measure and classify. Here first we have to measure the particular angle and then we have to classify the what type of angle. We will see here, this is I have to take in this protractor and we have to be ensure one of the arm should be coincident with the baseline, and we could see here this is 50 degrees angle. Now 50 degrees means it's less than the right angle, obviously it's a acute angle. So we can check the answer. I think here click the angle measure and try again. Oh, we have to enter here. Yeah, the answer is right, it's exactly 50 degrees angle. So this is the way we can easily navigate and we can get the immediate feedback and immediate experience with the different type of simulations of mathematics. As we know already, maths are a bit like abstract sense. When we do these role activities with the simulations, it could be a more concrete sense. And as we mentioned, this virtual labs not only for the teaching and learning, it could be for the assessment too. So each and every simulation we could get immediate feedback as a assessment, and the children also can experience as a self experience whether the answer is right or wrong, and they can self motivate it. So this is the way we can go with the simulation part with the help of these virtual labs.
Sure. And sir, there's assessment part as well. So we do not have much time left, but would you just navigate us through the assessment part? Maybe students can do the assessment part themselves.
Sure, ma'am.
Usually there are 10 questions in the assessment part, right?
Yes.
Okay. And once they do the theory and the simulation, I think they are able to do the assessment on their own.
Definitely.
Okay.
So at the end there are a couple of combination of, for example, an angle 90 degrees is called. Obviously once they are done, these are all hands-on experiences, they can easily answer as a right angle. So like that there is a combination of 10 questions. What angle is formed at the 3 o'clock. Obviously they can already know that each, like 1 hour indicates 30, then 3 o'clock it's obviously 90 degrees. Like that they can answer everything.
Sure. Thank you so much for demonstrating this entire simulation for all our viewers. Thank you so much, sir.
Thank you, ma'am.
Thank you to all our viewers. I really hope that you enjoyed this simulation. Do it at your own home, and I am sure you will be enjoying and you'll be ending up doing more simulations which are available on the Diksha platform. On the Diksha platform, there are not just simulations available for maths class, but for various other subjects, for various other grades as well. So feel free to attempt any simulation you want. Thank you so much once again, and thank you so much to our sign language interpreter Anushka for being with us throughout the program. And before leaving, let me just show you a glimpse of the schedule that we have for the entire day. You can see it. The next program coming up would be at 12 o'clock. This is our special program of teaching learning interventions for inclusive classroom, and this is going to be at 12 o'clock. But before that, there will be another program which there would be a maths program only at 12 o'clock, and later in the day there are multiple more programs. So do watch them and raise your questions if there are any at all. Thank you so much. I'm Tanvi Khurana, and now I'll take a leave of you. Have a great day ahead. Namaskar.